Okay, here we go. We got a couple of practice problems here to see if we can't clarify some things. So, our first practice problem, we have a present value. We have an initial investment, some start money, $5,000. We're going to invest that, getting paid an interest rate of 8% compounded monthly for 3 years. How much money do I end up with after this 3 years? Okay, formula. Okay, here goes our formula. Let's plug in what we know. I know what my present value is. I know how much money I start with. Let's go ahead and substitute that right now. Bang, 5,000, exactly right. I know the interest rate. The interest rate is 8%. Now, because there's division by 100 here, I'm going to write that 8% in there as 8%. Now, I'm going to end up dividing that 8 by 100 to turn that percent into a decimal. Okay? Compounded monthly, that means how many compoundings per year? 12. So K equals bang, good. And finally, for how many years? T equals 3. Very nice. Okay, now, PEMDAS plays a huge part here. We have to do these things in a certain order or we're going to get the wrong answer. So, of course, parentheses comes first and PEMDAS, but inside these parentheses, look what I got going. I got a few different things going on here. So, in this set of parentheses, I'm going to do the 8 divided by the product of 12 and 100. So 8 divided by 1200, I'm going to do that first and then add the 1 to it. All right, let's do it. So in my calculator, I am going to do 8 divided by 100 divided by 12. Now I can also multiply 12 times 100 and get 1200, but 8 divided by 1200, and then I'm going to add a 1 to that result. So in my calculator, fantastic. I still have 5,000 out front, and I still have this exponent here, but 12 times 3 gives me an exponent of 36. Now, don't forget, I have to do the exponent before I do the multiplication, so I have to raise this to this power. Now, on your calculator, remember you're looking for a button like this, or you're looking for a button like that to raise anything to any power. So I'm going to raise this 1.006 repeating to the 36th power. My calculator. And my future value is nice. Now, if I want to know the amount of the interest paid, I subtract 5,000 from that. Yes, sir. Yes, ma'am. That's exactly what I do. If I want to know the interest paid, I want to know the extra money on top of that 5,000. If I started with 5,000 and ended with this, the interest that I paid or the interest that I accrued will be the difference between the two. Bang. Very, very nice. All right. Let's try one more. Okay, here we are. Problem number 2. Now let's say I want to end up with $10,000. With an APR of 15% compounding semi-annually. What semi-annually mean? How many times per year? Bang, that's exactly right. Twice a year. How much would I have to initially invest? How much do I need to start with if I want to end up with that much money? All right, formula. Okay, let's plug in what we know. I know the future value. I don't know the present value, but I do know the interest rate. I do know how many times per year, and I do know how many years. So let's do all of that now. Bang, okay. My APR is 15%, 15 years, twice a year. Let's do some number crunching here. Now, if I can calculate all of this as one single number, I could divide both sides by that one single number. All right, let's see if we can't change all of this into one number. Let's do it. PEMDAS, remember we're doing inside the parentheses first. We're going to do this division first. We're going to add 1 second, and then we're going to raise that result to the 30th power. Let's do it. Bang, okay, that's what I get from everything inside the parentheses. Now I have to raise that to the 30th power, and that gives me bang. And now I can isolate that PV by dividing both sides by exactly right. These, of course, cancel. I'm left finally with my PV, and here's my answer. $1,142.21. I would have to start with that much money given these conditions to end up with $10,000 in 15 years. All right, guys, well done. We'll do some more of these in class. I'll see you soon.